This is CCNA1 Chapter 10 Part 2 about the network or the application layer protocols in TCP IP. And these are protocols that we are using every day, and I'm going to try to explain how these protocols are working and what they are doing. First of all, we have the HTTP protocol to browse the web. We have the SMTP to send emails, and also the post office protocol, the POP protocol, to enable users to receive mails. If we, for instance, look first at the hypertext transfer protocol, this is a protocol that will transmit and transfer HTML documents from a server to a client. The client will request a web page by the URL, and then the web server will send the page back to the client, and it will be shown in the browser. Typically, we are using the GET part of the HTTP protocol to just show the content of a web page. They all need to know or use the HTML code of the web server or the web page, and then it can be shown in the browser. For instance, here if we look at the URL HTTP www.cisco.com.index.html, HTTP will just tell us that we are using the HTTP protocol. The www.cisco.com is the server name, and the last thing, the index HTML, is the specific file name that we request the input of. If we don't do anything, well, then we can set up our web server to automatically show the index HTML file or something else, if you like that, the startup or setup or whatever kind of HTML. Typically, you set up your web server with a default HTML file that it will show if you don't put in a specific file name. Typically, there are different message types in HTML and HTMLS. HTTPS will then encrypt the content of the HTML packet that are sent. So, if we look at it, the HTTP can have three different types of messages, either GET, POST, and PUT. GET is a client request for data, and PUT is something that when the client has to put something up on a web page, either by POST or by PUT. If you're looking at the mail protocols, we have SMTP, we have POP, and we have IMAP. Always we are using SMTP to send mails from one mail server to another, and also typically from a mail server to a client. There are different ways of retrieving the emails from a server. Either we can just browse into the server and look and use the SMTP protocol for that purpose, or we can get the emails by using POP. When we are using POP, we are just contacting the mail server and just getting the emails from the mail server to our client software, client email software. The same thing with the IMAP protocol, that basically does the same thing, that it sends or retrieves the email from the server to the client software. The difference between POP and IMAP is that POP will then delete it on the server, whereas IMAP will keep them on the server even though you have retrieved them into your email program. Always when we are sending and receiving mails on the internet between different mail servers, then we are using the SMTP protocol for that purpose. And SMTP uses port 25, whereas the post office protocol POP is using port 110. And POP does not store messages, and some internet service providers are using POP because then they don't need to have a backup of all the emails. So SMTP is running and are used by both client and servers to send mail, and also between the servers both to send and receive mails. So here, if we have a mail user agent, send the mails through SMTP and to the mail server, and between the two mail servers here also we are using SMTP. This is a mail transfer agent. The mail servers, a mail user agent is typically a client. And here we can have a mail delivery agent, which is the POP3, for instance, where the recipient here, the mail user, uses POP3 to get access to the server, the mail on the server. Sometimes, when we are using it nowadays, we are using SMTP all the way through, both to send and receive from the client mail program. So, the mail delivery agent gets the mails from the servers, the MTA, the mail transfer agent. It receives all the inbound mail and places it into different mailboxes. This one can also, the mail delivery agent can also be have other types of functionality. For instance, it can do a virus scanning, spam filtering, and a return recipient handling if you want something, some kind of a default answer back or something like that. Yeah. So these three mail protocols are in use. Always the SMTP to send and receive mails between the servers, and also to send mails from client to servers. The POP or the IMAP are used to retrieve the mails to the client from the servers. And either on POP the mail is downloaded directly and it's not kept on the server, whereas on the IMAP the server will keep a copy of the email. Then we have the domain name service, the DNS protocol. The DNS protocol is used to translate the human names of a web page to an IP address, because we know now that all communication on the internet is sent to and from IP addresses. But we don't know the IP address. If I want to access cisco.com, I do not know which IP address that belongs to cisco.com. So I just ask my DNS server. I put in cisco.com in my browser, and then the browser will automatically, or my client will automatically contact the DNS server and ask, cisco.com, where do I find that? And the DNS server will look into its table and find out that this IP address here is the address of cisco.com, and this address will be put on the request when it's sent out on the internet. So on the internet we will see only the IP addresses, but we need to have the ability to put in names instead of numbers, because that is much easier for us humans to remember. So here the request is coming back, so the DNS server resolves the address, meaning that it look at the cisco.com and find out exactly which IP address that belongs to. So it's like a phone book or something, where you just ask for it, you have a name, but you need the number, and the DNS protocol will give you that. When we build up a DNS protocol, well then, or the DNS server, there are different types of records that we need. We always need an A record, which is the IP address or the address of the device or the domain. The NS is the name of the server, the DNS server. We can have an alias or a CNAME. And the MX record is also important, because not only do we use the DNS when we want to resolve a domain name, but also when we send emails, because emails is also sent to a domain name, and the MX records tell us the IP address of the mail server. We can see the content of our DNS by using the ipconfig /display DNS then we can see all the cached requests that we have made, because it will keep it in a local cache as well. When I request the same page a lot of time after each other, it will just keep them in the cache, and I can look down there instead of going out and asking the DNS server. The DNS hierarchy is built up by top-level domains, where we have the generic ones, which is, for instance, .com, .org, .mil, .net, .edu, which were the one that started out the internet. And then we have the different geographical domains, for instance, like .dk, .jp, .no, and whatever we have for all the different geographical domains as well. On the internet, there are 13 root servers, which knows the different top-level domains and can send the request out to the different top-level domain name servers. And then these will know the rest of the secondary level of the domain servers. For instance, if it wants to know the exact placement of cisco.com, well, then it starts by asking the .com top-level domain server, and then it can ask cisco.com domain server. So they are all built up in a hierarchy. No server, of course, know the entire all the different names on the internet. So they need to ask, but they ask up to the top level or the root DNS and then backwards down. So it will always try to look from the back of a DNS or domain name. For instance, easv.dk, it will look back and see from the backside and see .dk first. So it will ask the top level domain server in the DK domain if it knows where we can find easv, for instance. But they are all working together, and of course we need the domain names to be unique on the internet. We can look into our own domain name server by using the command nslookup. And then we can ask, for instance, where can I find cisco.com? And it will show us the IP address of cisco.com. We can also just try to ping cisco.com, and it will also show us the IP address of cisco.com. The next application layer protocol is the DHCP, or the Dynamic Host Configuration Protocol, where it's a protocol we use to lease an IP address or to get an IP address on the network. It will give us an IP address. It will also give us other things we need to be able to communicate with the network. For instance, the default gateway, the DNS server address, and other things. Also the domain can be given to us. So the DNS, we can set our computer to retrieve an IP address automatically, and then it will start searching for a DHCP server when we connect to a network. So our client will send out a DHCP discover, which is a broadcast, and then the DHCP server will answer back with a DHCP offer. So it will say, here, you can have this IP address. And then I will send an answer back, say, okay, thank you, I will get that one. And then the DHCP server will acknowledge that. In that way, I have been given an IP address. Next protocol is the file transfer protocol, which we use to send data between a client and a server. If we can have access to an FTP server where we can access different types of files and download them, we can typically also upload them. Sometimes we need to do it anonymous, so we can allow that, or we can have user authentication on. Typically, we are using port 20 and 21 when we are using the file transfer protocol. Another way of sharing files is by using the SMB protocol also, server message block. This is typically something that we will use between different types of operating systems. So for instance, when I have a Mac, I can use SMB to connect to Windows file shares, for instance. So I can see then the content of a specific file share. And that's it for this part.